Hello again. So this one, this thing. Okay, this video is going to be about actual probability. We're actually going to do some probability. Yay. But just as a reminder, permutations and combinations. I wanted to remind you that permutations are when you are choosing things that are going to be different, and combinations is when they're all the same. So a class of 27 must choose 3 students to represent them at a trivia game. So that is going to be a C because all 3 of the students are going to the same game. Order does not matter. And then you hit alpha window, and the first number should be bigger. It's how many you're choosing out of, and the second number is how many you are choosing. If you get an error, you put your numbers in backwards. Okay. And then a company must hire an assistant, an accountant, and a vice president from 16 applicants. How many different ways can they fill those positions? Well, those are all different positions. So it does matter. So there are 16 applicants and 1, 2, 3 jobs. Although, thinking about this, I really don't think that they would all be pulling for these specific jobs from the same pool of candidates. But, you know, again, it's just a math problem. Don't overthink it. Alpha window or math probability. Anyway, okay. So, cool. All right. Sample space. Sorry, I'm doing all these videos back to back, so it's getting old. The sample space is the list of all the possible outcomes. So suppose you roll a die and flip a coin. What is the sample space? Well, you can get a 1, a 2, a 3, a 4, a 5, or a 6. Or when you roll the die, and you can get heads or tails. So you can get heads with any number. Or you can get tails with any number. Ta-da. Awesome. Okay. All right. So theoretical probability of an event. You write it like this: the probability of A, whatever A is, probability that A is going to happen. And the way you find it is actually pretty simple. It's just the number of ways that A can occur. Oops. So I'll write that out. Number of ways A can occur over total possible outcomes. Hence why it was important to be able to figure out how many total possible outcomes there are. Interesting, huh? Okay. So we're going to start off really simple with these, especially since I'm not there to actually teach you. You're learning from past me in a video, and I can't answer questions. But your paper tutor could if you got on paper, or you could ask me, and future me might get back to you quickly, hopefully. I don't know. Okay, anyway. A jar contains 3 red balls, 5 yellow balls, and 7 purple balls. So find the probability, like, I meant to say, like, you choose one. What's the probability that the one you choose is red? Well, there are 3 red balls and 15 total balls. So if you do that, that would be 0.2, which is about 20%. If you want to know the percentage, you would multiply by 100, but generally probabilities are written as decimals. Just FYI. Okay. The probability of getting purple or yellow, will there happen to be 12 balls that are purple or yellow? And 15 total, which, like, literally you just do 12 divided by 15. You get 0.8. 0.8 there. So one of the reasons why this is important and why I did it this way is because these two are complements of each other. So technically, when I say probability of purple or yellow, that's the same thing as saying the probability of not red. It's the same thing. And there is something called a complement, which is denoted. So if you have the probability of A, the complement is written as the probability of not A, with a little apostrophe there. And you can't have a probability bigger than 1. All probabilities are between 1 and 0 because you can't have anything over 100%. There's nothing more than 100% likely to happen. And there's nothing less than a 0% chance. So a probability and its complement, when added together, is always going to equal 1 because the probability of something either happening or not happening is 100%. Like, it either is going to happen or it won't happen for sure. So anyway, okay. So then suppose you roll a 6-sided die. Find each probability. Well, the probability that you get 2 is 1 out of 6, which is 0.167. Probability that you get an even number. There are 3 even numbers on a 6-sided die, so that's 3 out of 6, which is 0.5. Probability of getting less than 5. There are 4 numbers less than 5 on a 6-sided die. So that would be 4 out of 6, or 0.667. And the probability of getting a 1 or a 6 is, well, there's 2 numbers that are 1 or 6, 1 and 6. So that's 2 out of 6, which is 0.333. So that's basic probability. Yay. Pretty simple, hopefully. But if you get stuck, ask your paper tutor or ask me a question on Google Classroom. And have a wonderful whatever day it is for you.